Today we're going to be talking about more multi-step equations. So far we've learned one-step, two-step, and equations that involve the distributive property. So now we're going to kind of take everything and put it into one big equation. There are definitely steps that you should take in the proper order to solve a multi-step equation. The first step, we're just going to do two examples, but we're going to go through all the steps. So here's example 1, 4x minus 24 equals negative 5 times the quantity 2x minus 10 and then plus 10. So step number 1 is going to be to use the distributive property, which you can see right here. I dropped my Apple Pencil tip first onto the hardwood floor, so now it only writes if I hold it straight up and down, so it's going to be a little bit challenging. So when you're doing your first step, everything else you're just going to copy down. So we're not doing the 4x minus 24 yet. We're not doing this plus 10 yet. We're just doing the distributive property. See, this is going to be kind of a challenge. So negative 5 times 2x is negative 10x. And then negative 5 times negative 10 is 50. And then we don't multiply this 10 by the negative 5 because it's not inside the parentheses. The next step is to combine like terms. So here is my next step over here. You can see that what I just solved is right here. This is after distributing. So I'm looking for like terms that are on the same side of the equal sign. So just have the 50 and the 10. And again, anything that I'm not doing on that step, I'm just going to recopy. The only thing I'm doing with this step is adding 50 and 10. The next step is to get the variables on the same side. So here are my variable terms, 4x and negative 10x. It doesn't really matter if you subtract 4x from both sides or if you add 10x to both sides. I personally like to have the variable term on my left. So I'm going to add 10x to both sides. 4x plus 10x is 14x. Hi, Romeo. And everything else that I didn't do during that step is just going to get recopied. Now it's a two-step equation. That's what we've been learning and something we should be able to do nice and quick now. Oh, there's the kitty. So we're going to get rid of our constant term first, which in this case is 24. The opposite of negative 24 or subtracting 24 is adding 24. So negative 24 plus 24 is just 0. And then 60 plus 24 is 84. Now I'm going to get rid of my coefficient. Since x is being multiplied by 14, the opposite is to divide both sides by 14. 14 divided by 14 is 1, so I just have a 1x, and then that's going to be what, 6? I don't have a calculator near me, so yeah. So 6. And as always, when you get an answer to a multi-step equation or any equation, you can check it by replacing the x up here in the original equation with 6 and see if it works. Okay, we have another equation here that we're going to follow the steps for. In this case, we have two places where distributing is happening. Right here, distributing with division, and right here, distributing with multiplication. So let's do the distributing first. Over here, 12x divided by 4 is 3x, and 8 divided by 4 is 2. So we're dividing this by 4 and dividing this by 4. Everything that I'm not doing in that step, I'm just recopying. So that, hi Romeo. So the negative 10 is not part of the distributing. I need to click off of the picture. There we go. So I'm just going to recopy it. Oh my goodness. Sometimes I just have to click for some reason off of the photo which is the notes, and then it works again. All right, and distributing on this side, I'm going to take the 2 times x to get 2x, and then the 2 times -8 to get -16, and then this minus x is not part of the distributing, but I can't forget about it. I'm just going to add it there at the end. All right, so now that is going to be written. Oh, it's not written over here. So I will write it over here. 3x plus 2 minus 10 equals 2x minus 16 minus x. All right, the next step is to combine like terms that are on the same side of the equal sign. So on the left, I have this 2 and this -10 that I'm going to combine. So the 3x does not have any like terms that are on the same side of the equal sign. And then 2 minus 10 is -8 because we have 2 positives and 10 negatives, so we have 8 more negatives than positives. And then on the right side of the equation, I have some like terms, a 2x and a -x. And so 2x minus x is just 1x. Oh, I wanted to change colors. And then we have that minus 16. The next step is to move the variable terms onto the same side. And so, like I said before, it doesn't matter if you subtract 3x from both sides or subtract x from both sides. But since I like to have the variable on the left, I'm going to move the x. So 3x minus x, of course, is just 2x. These guys cancel. X minus x is 0. And then I have a -16. Remember, I know I say it all the time, but remember that the sign goes with the number it's in front of. So don't forget that negative on the 16. Now it's just a 2-step equation for us to solve. 2x minus 8 equals -16. So I'm going to get rid of the constant term first. The opposite of subtracting 8 is adding 8. -16 plus 8 is -8, because if you have 16 negatives and 8 positives, you have 8 more negatives than positives. The last step is to undo the coefficient. The opposite of multiplying by 2 is dividing by 2, so x is -4. All right, since we only did 2 problems, I think there's enough time in the video to do these other examples over here on the side, following those 4 steps. So first we look for distributing. There are 2 places with distributing, so that's going to be my first step. 3 times x is 3x. 3 times -1 is -3. Don't forget that x over there. 4 times x is 4x. 4 times 2 is 8. Combine any like terms you can find on the same side of the equal sign. So I have 3x plus x is 4x. Everything else I'm just going to recopy. Then I'm going to get the x's on the same side, so I'll subtract 4x from both sides, and you'll notice 0x and 0x. So all the x's cancel, leaving me with this equation that has no x's in it. If that happens and the x's completely cancel out and you are left with a false statement, like this is false, it's not true that -3 equals 8, then we can say that this has no solution. There is no value for x that would make this equation true. All right, let's try this one. We're going to look for distributing. It's right there. So I'm going to just recopy anything that does not involve the distributive property. 12 times 1/3 x sounds hard because it has a fraction, but 1/3 of 12 is 4. And then 12 times 1/4, 1/4 of 12 is 3, so it wasn't too bad. And we're going to combine like terms. We have an 8x minus 2x is 6x. Everything else I'm recopying. Now I'm going to put the variable terms on the same side. Again, it doesn't matter if you subtract 6x from both sides or 4x, but I like to have the variable term on the left. My brain just likes it better that way. Now I have a two-step equation. I'm going to go ahead and solve by undoing the constant term first. 9 minus 9 is 0. 3 minus 9 is negative 6. And then I'm going to divide both sides by 2 because that's the opposite of multiplying by 2, and I get negative 3. One final example over here. We're going to look for any distributing. Actually, there's kind of double distributing here, huh? So first let's do the distributing in the numerator. 4 times 20x would be 80x. And 4 times negative 10 would be negative 40, and then we'll put that over 5. So we're not done distributing. We still have some distributing with division. So we'll do 80x divided by 5 and negative 40 divided by 5. So 5 goes into 80 16 times, and 5 goes into 40, negative 8. Now I just have a two-step equation. There were no like terms to combine and no variables we needed to put on the same side. So we're going to undo that constant term first. We're going to get 16x equals 32. And when we divide both sides by 16, we're going to get that x equals 2. One thing I did want to mention up here on this first example, remember how the exponent or the variable term canceled out and we were left with this statement, which is false, and we said there's no solution. If the variable terms cancel and you're left with a statement that's true, then you can say it has an infinite number of solutions, which means any number would work. So let's say your variable terms canceled out and you're left with something like 8 equals 8. That's true. 8 does equal 8, right? Then you would say all the numbers work. So you can say all solutions, all real numbers, infinitely many solutions, all of those kinds of answers are ways of saying that any real number would work for that equation. Thanks for watching.